Mbak Dr. Nia, please start. It's already 8 o'clock.
Okay. Good morning. Hello, everyone. I'm Kurnia Ningsih. I will be the moderator for this morning sessions. Title for morning sessions is Uncertainty in the Clouds, How Online Machine Learning Can Leverage the Natures of Its Dynamic Performance. Now I'm going to introduce our speakers. Our speaker today, Dr. Muhammad Hilman. He is expertise in clouds and distributed system researchers. He obtained a bachelor degree and master degree from computer science at Universitas Indonesia, and he obtained his PhD from University of Melbourne. He received a LPDP PhD scholarship and also Google PhD travel scholarship. His core skills such as programming language, clouds platform, workflow management system, and academic writing. So we will listen on his work on clouds and distributed system. Okay, welcome to all participants online via Zoom and also YouTube channel. So you can write your questions through Q&A in this box. Okay. And now I would like to invite Dr. Hilman to deliver talk. Dr. Hilman, time is yours. Thank you.
Okay, thank you very much, Dr. Nia. Good morning, everyone. It is still morning in Melbourne, in Indonesia, but it's quite midday.
How many
12 o'clock.
difference?
It's 4 hours time difference, so it's 12 o'clock in Melbourne.
Oh, okay.
Yeah. So thank you very much for attending this session. Now I will talk much about cloud computing. So basically my expertise is on cloud computing, but in this case, I will try to present how machine learning and artificial intelligence can be benefit for areas such as cloud computing and distributed system. Let me share my slide for you guys.
Okay.
Okay.
Yes.
Okay. Yeah, I think it's up now.
Yes.
So let me begin my session. Okay, thank you very much, Dr. Nia, Professor Vishnu, for the opportunity for me to present these topics. My topic is uncertainty in the clouds. So we will talk about clouds. What's clouds? Cloud computing, especially, of course, the term clouds refer to cloud computing, and how online machine learning can leverage the nature of its dynamic performance. So the other thing that we will learn is machine learning, especially online machine learning. What is online machine learning? Let's discuss about that kind of topic also. And the dynamic performance. So when we talk about clouds, we will face the dynamic performance. We will have the uncertainties in the performance. So these two topics, the uncertainty, which refers to the dynamic performance of the clouds, and the second one is online machine learning. The two topics, I will deliver the explanation and the session in this session this morning. Okay, my name is Muhammad Hafizuddin Hilman. This is my email. You can drop me an email if you have some further interest into my topic. Okay, just introduce myself. The profile, Dr. Nia has already been described that. I finished my bachelor degree in Universitas Indonesia at 2010, and then I finished my master degree 2012. And I began my PhD at 2016 up to earlier this year. Before pandemic began, I finished my PhD in 2020. So that's how my fortunate and so unfortunate condition of the world after the pandemic. my PhD works. I work in cloud computing and distributed system, Clouds Laboratory. That's the logo in the corner, Melbourne Clouds Lab, under supervisor Professor Rajkumar Buya and Dr. Maria Reed. I finished 4 years with them, and most of the work there is on the distributed system, especially the resource management in distributed system. What is resource management in the distributed system? So I work specially on cloud resource provisioning, scheduling and optimization, and also I took the case study of scientific workflows. So what is scientific workflows? We will learn about that later. In regard of scientific workflows, I work on workflow management systems, and also, of course, software development, building the prototype, software prototype of such workflow management system. Okay, let's begin our first topic today. The first I want to give some overview of what is cloud computing. Maybe some of you have already used this. Maybe some of you just heard about this cloud computing now. Anyway, I will explain as simple as possible about its term. Okay, cloud computing. Basically, cloud computing is a service provided by a computational service provided by some kind of provider, cloud provider. So they provide several services for users to use, and they separate the services into 3 layers basically. But in general, it is 3 layers. But some other providers also provide the service of others services outside of these 3 general layers. The first one is the most bottom layer of the cloud is infrastructure as a service. So simply said, infrastructure as a service is like when you need some computational hardware, you need CPU, you need memory, you need storage, you need any kind of computer, but you cannot have the machine. You can lease that kind of machine from the cloud provider. So the cloud provider provide you with a virtual machine, which can be bundled with several configuration of CPU, memory, storage, and any other things, and you can use it and access it remotely. This is the infrastructure as a service. We already know like Amazon Web Services, Google Cloud Engine, IBM Cloud, Oracle Cloud. They are all providing this kind of infrastructure as a service. So they provide you a virtual machine, and you can use that virtual machine for any kind of work or any kind of computational activity you have to do. The next layer, the second top layer of cloud services is platform as a service. So in this layer, the cloud provider not providing you with the raw machine of virtual machine, but they provide you with a fixed platform to develop your software. For example, you can develop image processing software, you can develop Java software, any kind of software in their platform. So they providing the platform, they providing the runtime execution, they provide the environment, and you can develop any kind of software on top of that platform without having a machine to install that kind of software. So basically, in infrastructure as a service, you need to do everything. You have to configure, you have to develop software, you have to install, you have to develop. In platform as a service, you don't need to think about how to manage the machine, how to install, how to configure the machine. You only need to develop your software. In the top layer, software as a service, you don't even need to develop the software. You only use their software. They have developed software for you, and you just use the software. It is the software as a service. Yeah, kind of software as a service is so common today, including like when you want to design, make a poster, for example. Adobe Corporation has provided Adobe Creative Cloud, so you access the software, the Adobe software on the cloud, you make poster on their software. You don't need to install the software. You don't need to pay for the license. You only pay for the subscription. They're basically different services of cloud players. The companies such as Amazon, Google, maybe you have to know about that, Microsoft, IBM, Fujitsu, and so on and so forth. That's basically the cloud computing. So basically the cloud computing is when you need to access the computer, when you need to access the hardware, you need to access the platform, you need to access the software. You don't need to think about how to install, how to purchase the machine, how to configure the machine, how to etc. You just need to pay the subscription, and you use that kind of facility in the cloud. So that's the general term of cloud services. So what makes the cloud computing environment? What makes cloud is so powerful? The first one is it is based on the virtualization. So they have the machine, real machine, I mean physical machines, and then they cover that kind of machine with middle layer of some kind of virtualization technology. And on top of that virtualization technology, they list the facility, computational facility, in the form of virtual machine. So when you access the virtual machine, you don't necessarily access the physical machine below the middleware actually. So this kind of virtualization simplify this resource management. The cloud provider can bundle your requirement. For example, I need a virtual machine with 4 GB RAM, 1 TB storage. You can define it, and the cloud providers can bundle your requirement and provide the virtual machine to you. But you don't necessarily access the physical machine. The cloud provider bundled it, isolated, and you access it in the virtual machine because of this kind of virtualization technology. But because of this kind of virtualization, there has a price that you have to pay. It is the overhead, the isolation overhead. It is obvious that when you access the virtual machine, the overhead of computational power will be higher than usual. The network overhead also will differ because you send the data, you access the data remotely. That kind of cost and price you have to pay. But so far, the cloud providers has improved their facilities. So with this kind of disadvantage, this kind of overhead, they will guarantee the performance for any users. So there is improvement in the technology that you don't need to worry about this kind of overhead. Okay, what is the other good things about the cloud? It is heterogeneous. It is heterogeneous. So when you whatever computational power you need, they will provide you. What kind of requirements, diverse requirements users have, they will provide. You need GPU, they will provide the virtual machine with GPU power. You need FPGA powered machine, they will provide you with that kind of machine. You need the machine that have high memory capacity, they will provide you. You don't need memory, but you need CPU power, they will provide you. You don't need CPU power, you don't need memory, you just need the storage to store your big data, they will provide you. Any kind of requirement, they will provide you and match with your requirement. It's heterogeneous. Even when you don't want to get kind of isolation overhead, they also provide non-isolated machine, which is called bare metal machine. So it's like they reduce the virtualization layer of that kind of machine, so you can feel the less overhead, real machine experience of their machines. So in terms of requirements, in terms of the configurations, it's very heterogeneous, and you can choose whatever you want from the cloud provider. The next step, the next offer from the cloud providers is very advanced. Including, as I said before, the bare metal services. The bare metal services is the services the cloud provided with less overhead. So basically, they remove some percentage of the isolation of the virtualization, and you can feel the real machine experience in bare metal layer surfaces. There's also microservices. It's the lightweight version of virtual machine. So when you try the virtual machine, you can see that it's so much overhead, it's so much delay. You can feel that, especially when you run some kind of application that require high CPU processing, high memory processing. So to provide the facility with less overhead, they make microservices. You maybe have heard about Docker. You maybe heard about Vagrant. You maybe have heard about Kubernetes. It's all microservices provided by cloud provider in the lightweight version of virtual machine. And the newest technology that they provide is serverless computing. So what's serverless computing? It's like when you get a virtual machine, basically you get a server, but with most virtualized machine, and it is accessed remotely. But basically you get a server. Precisely, you got a server that you can configure, you can install, deploy anything, any kind of things on top of that server. In these serverless services, you basically just you want to, for example, you want to run specific code without having to install anything, without having to manage and configure anything. You can use their service of serverless computing. So it's function as a service. It's called another type is function as a service. So if you have a function, a method, a part of code or a short of code, they will execute your code, only the code. You don't need to install the software. So this is basically the amazingness of cloud computing provider and technology that they provided. You can see the diagram here. The cloud is essentially multi-tenant. Multi-tenant means the same resource, the same facility is shared by many people. For example, let me show you the difference between single tenant and multi-tenant. In single tenant, we have a green virtual machine because it's all the same color. It belongs to one organization or one person. But essentially, naturally, in cloud computing, the virtual machine deployed on top of that kind of machine are multi-tenant. They belong to different organization. They belong to different person. So because of that, there are pro and con. The pro is it is shared by many people, so we can utilize the resource fully without wasting any kind of resources. But the cons is you have to share the facility together. It's like public transportation, a bus you share with another people. In terms of this pandemic era, when you share the facility together, when someone get virus, you may also get the virus. That's the trade-off between single tenant and multi-tenant. And cloud computing is essentially multi-tenant. But you can also build the single tenant infrastructure. For example, private cloud that you build for your own organization. It can be done. It's feasible to be done. But generally, the cloud is multi-tenant. Okay. This is from the survey of Gartner in November 2019. So in 2018, 30% of organization in the world, company in the world, use cloud for deploying their IT services. Next 2 years, the increase will be up to 60%. And the Gartner project that by 5 years, by 2025, almost all the services, 90% of the services in the world will be hosted in the cloud. It is some kind of good or bad news for us, actually. Good news is the company, when you have an organization, you don't need to purchase any kind of machine. You don't need to maintain the servers. You don't need to pay someone to do the maintenance, to to moderate, to administrate the server you have, you leave them to all to cloud providers. You only need to deploy your softwares, your information system, or your facility, or your requirement there. But the bad news is, it is still what we call it. If someone happened with that provider, your organization, your business process will be done. I've felt this kind of problem here in Australia. In 2017, the Amazon cloud in Sydney is crashed down. We don't know why. And you know what? Most of the activity in Australia is down. Because what? Because when you buy groceries in supermarket, there is, for example, in Indonesia, it's called, for example, Alfamart, Indomart. Here we have Coles and Woolworth. Their purchasing system is hosted in the cloud. So when the cloud down, you cannot purchase anything because the computer is shut down everywhere in Coles, in Woolworth. And another thing happened in 2019, last year, I think. Here in Australia, the ticket system for public transport is hosted in cloud. So you don't need to pay cash to the bus driver or train officer. You just tap the card on some kind of facility, cashless payment. This cashless payment is hosted on the cloud. So when the cloud down, what happened? Free public transport for like one or 2 days. So it's like free bus, free train for 1 or 2 days. So that's the cons of hosting our whole organization or business operation in cloud. When the cloud down, and it can happen, cloud can down, it can happen, and it's not impossible to happen. So the whole world, the whole activity will be messed up. Yeah, that's the cons of hosting everything in the cloud. The good news, another good news about cloud is they provide free services, free grant, free gift for researcher and student. So, for example, Amazon AWS and Google Cloud, they provide research credit for researchers. I've applied this before. You can Google it and try to access the website. So you need to write a proposal to them, and they will ask you how many credit you need, what the credit will be used for, what kind of research, how many virtual machine you need, and you write the proposal, and they will grant you a credit for using their facility. I've tried once. In 2018, I've got $2,000 credit, Amazon credit, for doing some experiment in the cloud. And also I've got $1,500 from Google Cloud to do the same thing. I mean, research credit. So you can apply, you can try to apply it, especially doctoral student, PhD student, or the lecturer or researcher in university. You can try to apply the grant. They will, when they grant you the money, the credit, you can use it for whatever you want for your research, of course. For students, they also provide this kind of service called AWS Educate. So in this Educate, but not particularly direct to the student, but it's for the lecturer. The lecturer can apply for credit for their student, for any kind of learning process. I've applied for my computer network class this semester. So I've got 150 students. Each of them got $30 credit to access AWS. It's not much, but it's good actually. So the students can learn how to use the cloud, how to benefit the cloud, how to, yeah, it's very nice. If you can try, if you want to try, you can try to register yourself or your student, your class into their services. That's all about the cloud, introduction to cloud. Let's go deep about the problem with the cloud. What is the problem in the clouds? As I mentioned in the title, it's called uncertainty in the clouds. So what is uncertainty in the clouds? What's so uncertain about clouds? Okay, I cite this work on 2016. So basically, because the cloud is, first, it is virtualization, it's virtualized, so many overhead, so many isolation overhead, and it's also shared between many persons, between many organizations. You cannot expect the consistency in terms of performance. There is this research in 2016 shows that different day and different week, the cloud provider will not give you the same performance. For example, if you use the cloud on Monday and you get some kind of performance, good performance, you might have better performance in Tuesday, but you may also get worse performance on Wednesday. So in Sunday, Monday, Wednesday, you may experience different kind of performance. And it is obvious because it's virtualized, because it's shared, it's multi-tenant. Yeah. Not just a day, even in a day, you might have different performance if you use the cloud, for example, in 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. So in the morning, you access the Amazon and it's still good. And then you access again in the afternoon, it's so bad. And when you go to nighttime, it's very worse. You can experience that kind of experience might happen. So the I/O performance, I/O bandwidth, these researchers measure the I/O performance of cloud instances, cloud services over the time, over the hours, and over the days. And they see the difference of the variation of performance, the performance variation. So the performance is varied over the time. For someone who doesn't need to, it's okay. I just run my software. I don't care about the performance. As long as my software is running, it's all good. But for some person who need like the exact kind of performance over the time, this may be a bad news for them. Because, for example, you run some kind of software that needs to be finished in 1 hour because it's so critical. You run that software in the morning and it finished in 1 hour. But then you run again the same software in the afternoon and it takes 5 hours to finish. It can happen, and it becomes a very problem for some kind of people. That kind of challenge that we face when you use the cloud services. Not only about time, the variability, the performance variability, it's also happen within a cloud instances. So, for example, when you use the same cloud instances from Amazon Web Services, the same exact virtual machine, for example, T2 micro, it's the configuration. It's called, for example, T1 micro. It's the kind of the smaller virtual machine configuration. You have two different T1 micro virtual machine. These two virtual machines can behave differently. It's obvious and it measured and it happened. So you cannot expect a constant performance, even though from the same configuration of virtual machine. Same virtual machine, different time, different days, different provider, they will not give you the same result. And that is actually a problem. So how we actually can benefit the cloud? We have to deal with the cloud in a manner that so it will benefit us economically, especially because we have to pay for the cloud services, and we don't want this to happen. So these two scenarios, you can see the diagram. These two scenario is something that you usually face when someone uses the cloud computing. The first one is called overprovisioning. So you don't want your activity to be interrupted. So when you have a demand of 10, you list the resources from cloud of 20. It's called overprovision because you only need 10. Why you list 20 capacity of cloud? It's called overprovisioning. So you can see the demand. The demand is lower than the capacity that you purchase or you list from the cloud providers. It's not economic because you pay more for something that you don't need. You don't use that, but you still pay for it. Or another scenario is under provisioning. So you have a capacity, you have a demand of 10, but you don't want to spend too much money of 20. So you think, I think if I spend 12, you get 10 demand. I think if we list 12 of capacity, it will be enough. And then suddenly in such time, sometime, the demand is peak, reach the peak of the demand, but just for a short period of time. It's still got, and when that happens, your operation, your business operation, your activities done is messed, because at that time the red part, the capacity that you list from Amazon is not enough to serve your need. Now that's called under provisioning. So these two problems can happen for anyone who decide to host their load, their operational in cloud. So we have to think a lot about this kind of way to deal with the clouds. Cost versus computational power. If you want cheap instances, of course, the power will not high. If you want high computational power, you have to pay more. Cost versus computational power. Or another problem, you have to choose between isolated facility, purchasing special cloud capacity just for you or your organization, versus sharing with the other users or the other organization. Okay, that's the the challenges that should be think about before you deal with the cloud. And the other problem is when to provision the cloud resources. Do we need to reserve do we need to reserve some kind of capacity beforehand before we deploy the software, or we can scale it on demand dynamically over the time? So now I can reserve 10 capacity, but when it peak, I scale up the capacity. Should we do that? Can the cloud providers provide that kind of services? That's the interesting question that we need to answer. And the other one is how to provision, because they provide so many variety of resources. There are so many heterogeneous resources. We have to choose the appropriate instances, and it's not easy. And the other things is how to tackle the performance variation, as we talked about before. The performance in the cloud is so varied, so changing over the time, changing over the geographical area. So everything is changing. So how we tackle this kind of variation? And of course, because it is heterogeneous, we need to carefully decide how to provision, which one we have to choose, which one we have to decide when we want to provision the cloud instances from the cloud. Okay, I hope up to this you can understand how the dynamic behavior of cloud environments and how it can affect your work, how can it affect the operational of organization, what kind of challenges we face, and what kind of benefit we can take on from this environment. Okay, in my work, I work on the spatial case study of scientific workflows. So let me explain a little bit about what scientific workflows. So scientific workflow application is a type of scientific application. Any scientific application, for example, maybe for now it's like drug design or image processing or video processing, any kind of applications. But it consists of different tasks that interdependently interconnecting tasks between one and another. Usually it requires a large computing capacity, large storage capacity, because the data being processed is so massive, and the need of CPU processing is so massive also. And also the bandwidth, because we need to move big amount of data over the network, so we need large amount of bandwidth. This kind of application is being considered in my work. So if you see the diagram, it's composed of different tasks, 1A, 1B, 1C, 1D. So in example, there are 4 different tasks. The difference is with a usual bag of task application, it is interconnected. So there are flows between tasks. For example, if 1A is finished, the output of 1A is being used by 1C to process, and so on and so forth. So this interdependency is define the flow between task to another. So it's called workflow. Yeah, basically workflow is some kind of interconnected task, interconnected processing between one and another. This kind of workflow utilize the data movement. So the output of one task is being used for input for another task. So if for example, workflow number 2, for example, if task 2A finished, it will provide the data for 2B and 2C. And when 2B and 2C finish, they will send the data to 2D to finish the processing. That's the workflow. And this workflow is not only scientific, there are also business workflow and any kind of workflow, but in my case, I use scientific workflows. Is it common for people to use scientific workflow? Yes, especially. When I begin this work, I also then realized that scientific workflows is widely used by scientists around the world. There's the social media of scientific workflows called myexperiment.org. You can access that website, myexperiment.org. It consists of thousands of workflows around the world that use from biomedical, bioinformatics. There's also seismic applications, astronomical application, many kind of application is being used around the world. And because of this kind of increasing demand of scientific workflows, I think my work is become relevant and contextual related to this community, scientific community that use scientific workflows to deploy their experiment. Okay, what you need to know about the scientific workflow? The workflow are modeled as direct acyclic graphs. So it's basically graph processing, graphs problem. What is the direct acyclic graph? It is graph that does not have backward flow. So the flow always forward. The flow of the task always forward. There is no going back. So from 1A always go to 1C. From 1C always go to 1D. There is no going back from 1C to 1A. So it's direct acyclic graph. So because of it is modeled as direct acyclic graph, this kind of model also relevant for someone or for people who works on data streaming. In data streaming processing, you will model the data as a direct acyclic graph, because when one data is streamed, they will connect it to another data that will come after that. And there is no going back because the data is always streamed forward. There's no going backward. So if you have interest on data streaming, it's also relevant for you to learn about my work, which is modeled the workflow into the direct acyclic graph. What are the challenges in processing DAG or direct acyclic graph? The first one is we need to preserve the dependency. Remember, because the output of one task will be used by another task. So this kind of dependency must be preserved all over the time. The second one is we have to manage a high volume of data movement. The movement of data is so high, so you need to decide whether you have to purchase more bandwidth or whether you need to put the data in some kind of places so it doesn't move too much, because movement means the load on the network will be added, will be increased. And the third one, of course, because it is interconnected, the way we provision the resource and also the scheduling constraint will be more complex, because when we want to schedule the task in this kind of workflow model, you have to consider the other task afterwards. So it becomes more complex and more complex. Okay. Now, how about we deploy the workflow, the scientific workflows in the cloud? The workflow itself is already complicated, already complex. so much constraints, so much dependency. Now we want to deploy this workflow into the cloud, which possess many kind of challenges: overhead, isolation, virtualization, cost problem, economic problem, and so on and so forth. So the challenges become so much. We can resume that kind of challenges into this aspect. The first one, the workload heterogeneity. We can deploy any kind of workload, of course. Of course, it is heterogeneous. Of course, the workflow is not only bioinformatics. The workflow is not only image processing. It also can be in the form of astronomical application, and it also can form in the form of any kind of application. So it's heterogeneous in terms of workload, in terms of the application being deployed. The second one, different people might have different quality of service parameters. So some people maybe want to deploy their workflow and being processed, being produced the result as soon as possible. But the other people may not want that kind of constraint. They want to just run the workflow, and I have this little budget. As long as it finishes, it doesn't matter how long it finishes, as long as it finished within my budget. So there are many quality of service diversity between different users. And because it is multi-tenant problem, and multi-users can deploy their workflows differently. So in my work, I work on developing some kind of platform for accommodating the execution of this application. We have to ensure the fairness and the priority problem of the user. So when users, different users deploy their application, we have to ensure that each of them get fair resources, get fair allocation, and so on and so forth. And these challenges in workflow side will face the challenges in cloud side. What is challenges in the cloud side? We have talked about this before. The uncertainties, the performance variations, the performance degradations, the overhead delays, any kind of delays, any kind of overhead related to the virtualization technology that become the backbone of the cloud providers. So this is my work. I developed the prototype of workflow as a service platform. So I add another layer in the cloud specifically for accommodating any people who want to deploy their workflow in the cloud. So it must accommodate large number of data because it is multi-tenant, it is multi-users. Any kind of users can upload can deploy their application here. So the data expected is quite high. The second one, I have to achieve near real-time workload processing because I cannot delay some users because, for example, the platform is so busy, the cloud is so busy, I cannot accept any new users. No, because it is a service or a service layer. I cannot have this kind of excuse like delaying some users because another user is using the facility. So I have to accept to accommodate any kind of user anytime they upload, anytime they request the execution of their applications. So it must be near real time, not real time. I think it's quite not possible to have real-time processing of workflow, but near real-time is okay. And the third one, it must be agnostic infrastructure. I mean, we can deploy in Google, we can deploy in Amazon, we can deploy on Oracle, we can deploy on IBM, we can deploy anywhere. We cannot lock into one particular technology. For example, we develop on Google, we only can use Google forever. No, we have to use any cloud providers available. So the system have to provision the cloud resources from any providers available in the world. In this topic, because I will talk about machine learning, I will specifically go deep on the task runtime estimator. What is task runtime estimator? When we want to deploy a workflow and we want to schedule and provision a specific cloud resources, we have to profile the task. For example, this task is data intensive, so we need to provision a virtual machine that have high memory, for example, because we need to cache as much as possible this data. Or for example, the other task is it doesn't need high memory, but it needs high CPU capacity. This kind of profiling will decide which cloud resources we will provision, we will list, we will choose. So this aspect, the task runtime estimator, is important. But specifically, this estimator or this prediction machine, or this, what we call this, a model, machine learning model, or this kind of module, learning module, has to be fast, has to be reliable, has to be efficient, has to be low cost, that's important, has to be low cost, and has to be seamless to or agnostic to various infrastructure. So this model can work well on Amazon, should be work well also on Google, and so on and so forth. So this kind of prediction have to be built and become a model that can accommodate this kind of requirement. So what I have, what I did in building this estimator, this prediction, I first search on different kind of approaches people have done to develop a prediction model, the estimator model, machine learning model to work on this kind of infrastructure. It has to be fast, it has to be reliable, it has to be efficient, it has to be near real-time processing, it has to be agnostic. The first one is they use some kind of statistical description, usual statistical description, providing the task, make a model of a task by providing them based on simple statistical descriptions. So, for example, like let's run this task on various virtual machine, and let's find the average, for example, the mean or the standard deviation of each task. Let's do this kind of approach, and let's write down the data, and this statistical description will be applied as rules to decide which kind of cloud resources we will provision. Another one using the sample profiling, small sample profiling. So if you got a large number of data, a large number of tasks, let's sample small of them to run on particular distributed system or particular cloud instances. And based on this small sample, then we decide which kind of infrastructure we will purchase, we will use for this type of task. So the problem of this profiling method is it highly depends on specific infrastructure. It doesn't meet our requirement of agnostic infrastructure. And the last one, of course, the most popular one is the researcher use machine learning. Use machine learning to predict the behavior of a task when it is deployed in the cloud. By what? By deriving several features of this task, and then based on that features, they develop a model that make a relation between the features and the output, the expected output of the task runtime in the cloud. So based on this model, they then predict if this kind of task is being deployed to the cloud of these particular instances, they will get this particular performance. So yeah, it's the best, the most popular, I'm not saying the best, but it is the most popular way to do, the easiest one, especially the easiest one, and the most relevant to our requirement. So we choose the approach. what we do, what kind of model we develop using the machine learning model to predict the task runtime of scientific workflows in the cloud. So we build a resource monitoring model. So the running tasks are continuously monitored in terms of CPU usage, memory usage, bandwidth usage, thread usage, and all of things we measured. And we keep the record of each task in a series of tuple. So it's basically a tuple of time series data. So it's time series data. The tuple consists of timestamp and the value. For example, I provide the example of thread monitoring of particular task. We monitor the task every interval t. Different time will provide different graphs, different graphics. In the left side is the thread monitoring of 1 second. Every 1 second, we capture the data and we record the data in each second. The right side, we record for every 3 seconds. So when we record the most granular way, for example, in the smaller time as possible, 1 second, 2 seconds, we will have more distinctive pattern. But if we capture in the more time, for example, more interval, the graphic will be less meaningful for us. But if we want to capture the data in small time frame as small as possible, of course, the cost will be high in terms of storage. The data will be big and will be massive compared to the more time frame. From this monitoring model, from this monitoring time series data, we extract some features. There are two kinds of features that we extract. The first one is called pre-runtime features. So pre-runtime features is not time series. It's not. It's given. I mean, given task and its noun environment we set as pre-runtime. What is given task and noun environment? For example, in terms of task, we can derive the features such as size of input, size of code, size of the data, or in terms of cloud instances, we can extract the information such as how big is the memory, how big is the CPU capacity. That's called pre-runtime because we can retrieve these features before even the task is being deployed in the cloud. We can know that beforehand. So it's called pre-runtime. And the second one is the time series resource monitoring data, which I explained in the graphics. It's called runtime features because this data cannot be achieved, cannot be collected, cannot be extracted before the task itself being run in the cloud instances. So it's called runtime features. We extract these two features and make a model. Okay, so this is the detail for each features. The pre-runtime features consist of task name, task ID, task input, memory of the virtual machine, storage of the virtual machine, virtual processors or CPU capacity of virtual machines, and submission time. Why we include submission time into these pre-runtime features? Because we know that cloud may behave differently each hours, each day. So we may want to include this time features as pre-runtime features. And of the runtime features, we measure CPU, the resources, number of processor, time spent in user mode, threads, user time, resident set size, virtual memory usage, I/O also, I/O weight, read character, read bytes, sys characters, sys read, sys write character, write bytes, and so on. So basically, we monitor all of the runtime resource parameters in terms of CPU, memory, and I/O. The pre-runtime features is not time series. It's a set of static and specific information. But the runtime features, we stored it in the form of a time series data model. Okay, our proposed approach is we leverage the online machine learning to capture, to handle the dynamic performance variation of clouds. What is online compared to batch offline way of doing machine learning? So I provide some kind of simple, it's very simple illustration. So if in online incremental, the data, incoming data is modeled as a stream data. So one data will come, and then after that, the second one will come, the third one will come, the fourth one will come, and so on and so forth. So it's streaming. The data is come over the time. When the data come, the robot, the machine learning model, will read the data and decide, should we use this data to update our model, or we don't need, we just dispose this data. We don't need to use this data to update our model because we have seen this data before, and so we don't need to include it into our model. So basically this is online, and it is incremental because the existing model, the existing machine learning model can be updated whenever the robot see new data. Whenever the robot see new data, they will, and oh, it's important data. We need to remember this and update the model. So it's basically a stream of data, read by the model, update the model. So when the data come, should we dispose or we remember and update the model? So that's the way how online and incremental machine learning works. Online must be incremental, but incremental not always online. Incrementals mean updating the model. We can do that also in traditional way. For example, if the data in big data environment, when the data is so big it cannot fit into the memory, we can put the data into the memory in batch side. So for example, 1 GB, process, build the model, and then put again 1 GB and update the model. It's incremental, but not necessarily online. In my case, it should be online and of course incremental. The data should be online because it's streaming data, and also incremental. The model should be updated incrementally. Compared to the collection of data in batch offline way, the data should be collected first in whole chunks of data before the machine learning model can interpret and make a model. So basically that's the simple explanation of difference between online incremental and batch offline. Okay, so this is the algorithm, very simple algorithm, because I'm not a machine learning expert. I'm not artificial intelligence expert. I'm more of a distributed system researcher. I use the machine learning to leverage and to match with the distribution system dynamic performance problem. So I try to make everything as simple as possible, so everyone will understand easily what I use, what I do, without having some technicalities problem of asking this equation formula and so on and so forth. So basically, this algorithm works like this. When I got the task and I got the cloud resources, cloud instances, I extract the pre-runtime features. Okay, I extract pre-runtime features, and after that, I got the runtime features estimation. So from the pre-runtime, I estimate the runtime features. For example, if I'm given this kind of particular task and this particular virtual machine, can I predict the runtime features or the estimation of the runtime features of this task and cloud instances? Okay, how can I estimate the runtime features? From the time series record that I've got from the previous experiment, from the previous execution. So I predict the runtime features, and then I do the time series runtime feature extraction. I predict the series, the time series, and from the time series, I extract the runtime features. Okay, and then combining the pre-runtime and runtime features, I combine both of them and do the predictions. So I use, for the time series runtime feature extraction, I use time reversal asymmetry statistic by Fulcher and Jones in 2014. It's quite good because it works well for data stream and time series data, because it considers the window to process the data. Yeah, it helps the robot to decide in such particular window which data should we keep and which data should we dispose. Okay, so this one is the comparison. I compare my work on the baseline. So the baseline only use pre-runtime features to predict. The second method already use runtime feature extraction estimation, but they don't model the runtime features as time series. So it's not. So my additional work, especially in the runtime feature estimation, which I modeled the features into a time series data. Basically, this is the comparison. Okay. The first and the second approach is not online. Basically, it's still a traditional way of machine learning, offline machine learning way. So we recreate their algorithm in online approach, and then we compare their online version of approach with our algorithm using bioinformatics workflow. So I got two different workflow. The first one is 1000 genome. It's DNA thing. I don't know what it's detailed, but I know it's processing the DNA of human DNA and finding the disease that related to the DNA. It's quite big workflow. It consists of 23,000 tasks. And the second one is virtual screening workflow. I know this well because my bachelor my bachelor thesis, my script C is working with pharmacist researcher on this virtual screening. What's virtual screening? It's basically finding drugs using mix and match between different candidate of drugs with the protein. I also use this workflow. It consists quite big task, 15,000 tasks. In this work, I use software called Pegasus Workflow Management Systems. It is the software that used for managing the workflow execution. You can guys check it out on their websites. It's good if you have interest on workflows. You can use this software management system. It's very good, very reliable, and also it accommodate my requirement to monitor the resource, computational resource. So it has monitoring capabilities using the module called Panorama. And I deploy this experiment on Nectar Research Cloud. It's basically Australian-based research cloud. Every student and researcher can use Nectar. I use different configuration, different flavors of a virtual machine to prove that this algorithm works well in choosing different configuration of virtual machine. Okay, so the first result that I present is I will compare my algorithm with their two approach, which I have recreated it into online. So basically, the first table is all online approaches. Baseline is the baseline. Two stages is two stages algorithm. My algorithm it's the column of time series. I have 1, 2, 3, 4, 5, 6, 7, 8 different t intervals. So because I want to know if I set the time intervals small, how is the result? If I set the interval big, how is the result? And the result is like this. For different tasks, different parameters, different time interval parameters produce different results. So the best case is that I bold I put in bold. So that's the percentage, the error percentage of the predictions. Okay, that one, the online one. I got 5 different tasks: individual merge, mutation overlap, frequency, orthodox binary. So that 5 produce different percentage. Basically, if you want to simplify your reading on the table. If it is small, it's good. If it is big, it's bad. So simply like that. Error is, when we got error, we want the error as small as possible. So the smaller the error, good news for us. And then I also compare, we know that, okay, online incremental is good and is accommodating the requirement of our work. How if we use the traditional batch offline approach on this kind of problem? We can see that in terms of batch offline, we can get quite good or competitive result compared to online if we collect the data up to 80% of all of the data. So if we have to collect, or if we collect all the data up to 80% of it, we can achieve the competitive result. But in this kind of environment, when the data is streaming, data is streamed over the time, we cannot like put together the data first, wait until it 80%, and then we build the model. No, because every time the data comes, we have to process as quick as possible and then produce the results. So yeah, we choose online incremental approach for this problem. This is the graphic presentation. If I present it into more histogram, so yeah, it's quite good. The first result is achieved without feature selection. So I also experimented more when I have the model. How if we do the feature selection? If we select the most appropriate features, not use all of them, but just choose particular features to build the learning model. So the first one is basically the table data put into histogram. The second diagram is different result when we compare the result if we do the feature selection and without feature selection. So we can achieve more better result when do a feature selection. Okay, I didn't explain the feature selection. What is feature selection is because it's out of the topic, but basically feature selection is when you have set of features from research monitoring capabilities that I mentioned before. You didn't use all of the features for training the model. You only choose 2, 3, or 4, or just a subset of the features to get a better model for your estimator. So yeah, that's basically the feature selection. There are many ways to do feature selection. So that's basically, in my work, I use Pearson's value to decide which features I should use for a particular task. So yeah, that's it. All my work on online machine learning to predict the task runtime of scientific workflows when we deploy them in cloud computing environment. So yeah, this kind of approach is not new. I mean, everyone uses the online machine learning, but in terms of leveraging the benefit to the cloud computing environment is quite new. I mean, I passed my PhD on this work, so yeah, it's new and novel. But in other area, I have read several area using online incremental machine learning. It's so many and so much, and they use this kind of approach on especially on data streaming data, near real-time processing data, and so on. It's that kind of data. Okay, so that's all. My session today. Thank you very much.
Yeah, thank you, Dr. Hilman. Yeah, okay, this is very great talk and very interesting because now I'm also still doing research in machine learning in streaming data. So, okay, I would like to read some questions in Q&A here. Okay. Okay, from Ada Ozi. I want to ask, as a new cloud computing user, does each different platform have a different language?
can I answer
please.
the question directly or? Okay.
Please, you answer.
If you are new to the cloud computing, basically they provide everything. Basically, they provide everything. You need Java, they provide Java. You need Python, they provide Python. So don't worry about that. If you talk about infrastructure as a service, you can install your own software, your own platform, your own library there. But in terms of platform as a service, they, I think, provide various type of language platform development. Java, Python, anything. I think as far as now I know, they provide everything. Well, truly, they will provide everything. Yeah, so you can choose any provider, but you have to check, especially, but in big providers such as Amazon, Google, and IBM, I think they will almost provide everything. But in smaller cloud provider, you have to check it first whether they provide the platform as a service that's suitable for your language development.
Maybe Dr. Hilman, could you please also give tips and tricks for a new cloud computing user? Maybe first time they want to start using cloud computing. Which one also is better amongst Amazon's or Google or Alibaba or others? Maybe you have another tips that you can share to the new user.
Sure. For the new user, the first one is every cloud providers provide free trial. They provide free trial of the services. So you sign up. I recommend you use the first one is Amazon or Google. They provide quite big period of credit and time for new users. So, for example, Google. If I don't mistaken, Google will give you $500 for free for a new user. So, $500 is kind of 6 million, right? 6 million is quite good. Yeah, you can try first with that credit to like deploy the virtual machine, install software there, configure things, and that. Try it first. But there is best case rule of thumb of using cloud. The first one is you have internet. If you don't have internet, you cannot access clouds. Definitely. So you have to got stable internet connection. That's mandatory. When I first learned about cloud in 2008, 2009, I think my first script C is on cloud also. So it's so hard to get the cloud because you cannot get that stable internet connection in Indonesia. So I have to spend my time in campus because they got stable connection. When I do in my dormitory, in my kos-kosan, I cannot get that kind of good connection. But nowadays, I think, well, the internet in Indonesia is all good. I think you don't worry about the connection. I think everywhere is good. The second one, because you pay for any virtual machine you deploy. Remember, when you deploy virtual machine, you pay. Even though it is free trial, I mean, for the new user, you got free credit, you still paid. I mean, the credit you got will reduce whenever you deploy a virtual machine. So don't forget to turn it off. When you deploy virtual machine, you access the cloud. When you leave the cloud, don't forget to shut it down.
Don't forget, yes.
Don't forget to shut it down, because if you don't shut it down, they will charge you
billing
over the
continuously.
Time.
Yes,
the billing is continue.
I had a bad experience. For 1 month, I didn't realize. So billing charges until more than $300.
That's the another important things you have to remember. And the third one is, when you're accessing the cloud, you are accessing it through some kind of key. Not only password, but key. So they provide you with key, some key, set of number, some kind of key. Don't forget to secure your key. There are people who forget that when you develop application that is being deployed in the cloud, you put the key as a hard code in the in the code, in your line of code. You put that key there, and then you upload that code somewhere else in the Git or somewhere else in the website. Everyone can see the key. When you lost the key, I mean, when every other person has your key, they can access your cloud, and they can do whatever they want out of your consciousness. So basically, to secure your access, secure your application. And also, yeah, part of the secure access, don't access the cloud from, like, let's say, open internet access point, like Wi-Fi in Starbucks, for example, or Wi-Fi in McDonald's, Wi-Fi in park, or in internet cafe. Don't do that. It's so unsecure. Everything can happen in that kind of environment. So make sure to secure your access, your cloud access. You can use VPN, for example. If you, I still have to access the cloud from Starbucks Wi-Fi. So how can I secure my access? You can use virtual private network, VPN, for example. Yeah, it's better that way compared to use open Wi-Fi, for example. Yeah, that's the very basic tips that even the experts still forget, like me, still forget of that basic rule of thumbs of accessing the cloud instances.
And maybe also you can give suggestions to the new users. Maybe if there are many options of data centers located like in Singapore or in US or in Europe, when I compare, the closest to us, the more expensive the price. And yeah, that's why when I checked the billing, data centers in Singapore is more expensive compared to the data centers in like Oregon and others.
Yeah, that's correct, Mbak Nia. So when we deploy, when we create instances in cloud, we can choose where our cloud will be based. There are several. The nearest one is Singapore, Sydney, I think, and then somewhere in India, somewhere in Japan, South Korea. The most of them are in United States, of course. You have to know that when you choose the farthest one, you remember the logic of network. When you use the farthest one, when you transfer data there, when you download the data from there to your laptop, the network overhead will be higher compared to if you choose it from the closest location. But also that one, the second one, like Mbak Nia said, Singapore data center is cost more than data center in United States. So you have to think about of your application. If your application is time critical, network sensitive, maybe you have to spend more money and choose the closest location, because you have to upload it quickly, download it quickly. But if you don't care about this time constraint, you can choose the cheapest one far over there. Yeah, that's correct. That's the correct approach.
I agree with you. Actually, the difference time also not too big. Yeah, but I don't know. I never compare to data centers in Europe or others.
Yeah. Okay. When you upload, Mbak Nia, when you upload like 100 megabyte, 1 gigabyte, it doesn't matter actually. It doesn't. Yeah. But if you have big data, 1 terabyte, 5 terabyte, wow, it's become a big problem.
Yes, I agree with you. Yeah. Okay. Next questions. Okay, from Chut Ahmad. Okay, as you said before, one of the conditions of cloud systems is it just have one source. So when it's down, everything connected to it is also down. Is it possible for government to make their own cloud system? Yeah, I think this is also related to another questions I saw similar like Mr. Tosan, yeah, and also Mbak Rizka. Yeah, regarding government data, yeah, due to data sensitivities, yeah, as we know that Indonesian government regulations are not allowed to put some sensitive data outside the country. So what's your opinion regarding this?
Okay.
Mas Dr. Hilman, maybe I just want to make some additional information. Actually, Mas Tosan, Mbak Rizka, and other attendee who give the question is the student from doctoral degree in Faculty of Computer Science. Because in our faculty, and as government says, we must have a supercomputer or high performance computing to calculate our own data. Because when we send the data in the cloud, the meaning is we cannot, keep guarantee the security and so on. And now our government force us to make we call one data, and every data, every data in the department must access or must in Indonesia, or we must make a data center in Indonesia. And okay, this is related with the Mas Tosan question and Mbak Rizka and other attendee question. Okay, maybe this is help you to maybe to answer, because the rule, the regulation is not allowed when we submit all of data in the cloud. Okay, thank you, Mas Dr. Hilman.
Okay, thank you very much, Prof. Wisnu, Mbak Nia. Yeah, it's the biggest concern because the companies will sell the ketchup, like jualan kecap gitu kan. Every provider will sell their product. Oh, it's safe, it's secure, it's very good. Everything is just ketchup gitu kan. So yeah, that's correct because
lah gaya marketing ya.
Yeah. That's the case here in Australia. So in Australia, they put the data here in Australia. I mean, they put the data. First thing first. It doesn't matter you outsource your facility to other companies as long as their facilities is within the territory of your law. So in Australia, they actually outsource their processing to Google, IBM, and Amazon, but onto their facility in Australia, in Sydney and Melbourne. So whenever the government need to access the data, they can access it easily because it is within their territory, their law enforcement area. That's the problem when you send the data outside your area. For example, Indonesian's government data is sent to Singapore. You don't know what can happen there. For example, you want to open some kind of secretive data there, and it is outside your territory. You have to send the letter to the Singapore government, and so bureaucracy and so on. So it's so hard to think, so complex. So the first thing first is you have to build the data center here in Indonesia. Not necessarily your own data center, because if you want to manage your own data center, your own Indonesian cloud, in my opinion, it's too hard. Do you have enough resources to maintain that kind of facility? I mean, if Indonesian government want to build their own cloud system, they own their own, they build from the scratch the data center and they manage. My question is, do you have the capacity? Do you have the resources to do that? To maintain that? Do you have enough expertise to maintain that kind of facility? Because it's so resource consuming. In my opinion, you can, if I were a consultant to Indonesian government, you can actually trust the private sector company, cloud private sector company, as long as they have the data center in Indonesia. So the first thing first, you have to make them, Google, Amazon, IBM, any company, you have to make them, you have to force them to build the data center here in Indonesia. That's the first one. Because after that, that's the first thing. I think you have to make sure that the data is here in Indonesia and within the enforcement of law enforcement of Indonesian government. So that's the one. The second one related to the if one cloud system down, everything will be messed up. That's correct. So you don't put egg in one basket. That's the
That's a big.
I mean, it's the common sense approach. When you have one so much money, you don't invest in one company, right? You put in several companies. So when one goes south, you still have the money in other companies. That also works on backup data. So that's why you can use and utilize either one company with different data center. For example, in United States, Amazon have a data center in several locations. Or you can also use several companies to have the backup of the data.
Yes,
that's the right way.
Yeah.
So that's the question.
I agree with you. Yes. Okay, but I couldn't imagine if a company from outside and then they build data center in Indonesia. Is this how about the electricity power in Indonesia? As you know that kita sering mati lampu gitu loh.
Yeah, I know.
The big problems, yeah.
Yes. Once I when in my master study, I once accompany Professor Heru to what institution in Ragunan?
Undip?
No, Ragunan, South Jakarta. Cyber Badan Sandi Negara or what? Yeah, Badan Sandi Negara, Badan Cyber dan Sandi Negara, BSSN. I don't remember the name. That headquarters there. They said when they activate their high performance computing facility, the whole kelurahan, I don't know, kelurahan or kecamatan, the electricity is not enough to power their machine, so it's go down. So yeah, that's another problem.
That's why
I think that's also the other thing that
the main problems.
Yeah, no cloud providers build their data centers yet
in Indonesia. Yes.
Yeah, but if Indonesian government want to put their data in the cloud, that's the first thing to do. Forcing the company, forcing the cloud provider to build their data center in Indonesia. That's the first thing to do, I think, in my opinion, before thinking about one data system, putting everything on the cloud, accessing together, and so on and so forth.
Okay.
Yeah, that's it. And also the internet connectivity, of course. Electricity and the internet connectivity.
Of course, have a big support from the government.
Yeah, that's why I think, in my opinion, the role of Indonesian government to support this kind of problem, not by developing their own cloud system. No, I don't think that's the appropriate role for Indonesian government. It's so much effort, so much resources. I think the role of government is enforcing the company to put their data center in Indonesia, and the government can guarantee that the electricity is enough, the internet connectivity is good. That's, I think, what government can do in related to this.
So, we can attract company to build data center in Indonesia as long as the government gives a big support to them, right? Like electricity and others. So it will be a good for us. Yeah. Okay, thank you, Dr. Hilman. Next question is from Mas Saptaji. I think it's my students. One of these advantage using cloud computing, especially in Indonesia, is poor internet connections. Yeah, I actually already discussed just now how to improve that. For example, if I have a voice recognition app using Google API, if I have good internet connection, my app will return good response from Google server. But if I locate it in a bad internet coverage, the response will be very varied and sometimes return wrong recognitions. Any suggestion?
Yeah. That's obviously that will happen. So I think one of Professor Wisnu's student, Siapa Pak Wisnu? Ini Binus Pak Wisnu?
Muted. You are still muted, Pak Wisnu.
Pak Sani, Pak Agung.
Pak Sani. Pak Dr. Sani, thesis is all about the compression. I think that's the solution of internet connection. So when you have bad internet connection, means bad internet connection means bad signal, means bad bandwidth, small connectivity. So the best way is don't send too much data to the internet. Or if you have a large data to be sent to the cloud, you have to compress it as small as possible so the bandwidth can cope with that kind of size. I think many researchers works on this, especially in Indonesia. When we talk about telehealth, you need to send the data from the remote area to the city area. You know, the internet is not so good. So you have to compress the data as small as possible, as long as the information is not lost. I think that's one. So you don't take the internet for granted. Maybe in your app, you have to include this kind of factors. I mean, the compressions when you send the data. I know it's not a machine learning area. It's not a software developer area. It's more of the networking area, computer network. So how to calculate the small bandwidth or size of the data, compression, and so on and so forth. But anyway, if you work on this kind of scenario, you have to consider that kind of factors. You have to include these factors into your software, I think, in your app.
So data compressions without losing data integrity. So
Yes.
Data compressions have to consider data integrity, right? Okay, and the last questions. Oh, almost finished. Okay, last questions, quick. What is the trickiest part of managing a cloud infrastructure when we implement database in clouds? From Mr. Sukamto, my colleague. Okay.
Yeah, I think the trickiest part is, you know, the people, the expertise, the human resource, because employing someone as a network administrator, I don't know, database is not my area, but basically when we put things in the cloud, the problem will be still the same. It's parallel accessing, distributed transactions. So same idea, whether it is database, whether it is this common application. I think the general problem is still the same, but in depth of database, I don't know. I'm not expert on database, but the trickiest part is, you know, providing the expertise, the human expert on administering the transaction, troubleshooting the transaction, you know, provide solution for the problems. In Indonesia, I think that's the hardest part, because when you want to build your own infrastructure, this kind of infrastructure, and no expert hired for this kind of problem, you know. Does my sound still okay?
Yes.
Yeah, that's the trickiest part. Not technicalities. Yes, technicalities, but technicalities means the person, right? I mean, if the problem facing technical this on that, and you don't have an expert on doing this dedicatedly, it hard to. Even here in Australia, you know, jobs opening for cloud architect, solution cloud expert, system network engineer, it's still hard. The resource, the human resource, is still rare. So if here there are students of bachelor degree, master degree, and you want to work on this problem, cloud computing, distributed systems, network system, you know, there are so many jobs opening here in the world, not in Indonesia only, in the world. If you want to pursue this career, I think it's very good to you if you want to expert in this area, because as long as artificial intelligence and big data is increasing the popularity, you know, cloud computing will always follow, because they cannot do anything without the backbone, and the backbone is cloud computing. So as long as it increases, the cloud computing will always follow.
Okay. Yes, agree with you. Thank you very much, Dr. Hilman. Okay, dear participant, please give applause to Dr. Hilman. Thank you for your great talks. Okay, please give prize. Okay. Thank you, Mas Hilman. Okay, dear all participants, thank you for joining us today.
Dr. Nia, as I mentioned before the presentation, Mas Dr. Hilman, can you conclude your presentation in Bahasa, maybe 5 minutes, 10 minutes?
Yeah,
so
I
that
will
maybe...
conclude my presentation in Bahasa Indonesia.
Bahasa Indonesia,
I hope my English is understandable, but regardless, I will talk in Indonesia to conclude my speech. Oke, jadi terima kasih atas kesempatannya. Jadi topik kali ini kira-kira kalau saya bahas itu kan menjadi dua. Yang pertama adalah uncertainty di cloud. Cloud computing, challenges-nya apa? Challenges-nya terutama yang tadi saya bilang uncertain. Tidak ada yang pasti di cloud. Tidak ada yang pasti in terms of apa? In terms of performance, in terms of up and down. Nggak ada yang pasti. Walaupun semua perusahaan menggaranti kita kecap paling manis, nggak ada. Tetap aja kasus-kasus di mana cloud system down itu sering terjadi. Terakhir di Australia juga itu membuat lumpuh semua pusat perbelanjaan. Ya kacau lah gitu kan. Jadi itu uncertain. Uncertain itu adalah masalah utama. Karenanya ketika kalian mendeploy aplikasi atau meng-create skenario arsitektur, mesti memperhitungkan itu. Nah, makanya yang dibahas di sini adalah dalam riset saya adalah bagaimana men-tackle gitu ya uncertainty itu dalam proses prediction, memprediksi runtime dari sebuah task yang dijalankan di cloud. Karena cloud itu tidak pasti, maka cara-cara tradisional tidak bisa kita pakai. Maka salah satunya adalah menggunakan online approach dalam machine learning. Nah, kalian bisa pelajari lebih lanjut online approach itu kayak gimana, tapi kurang lebih tadi simpelnya adalah online itu kalian memiliki data yang near real time, gitu, yang stream datanya, gitu ya. Datanya stream, tidak bisa dikumpulin dulu, baru diproses, tapi harus stream. Kan ada banyak skenario yang harus di stream. Nah, itu bisa pakai online. Dan incremental. Jadi, model yang udah dibuat bisa diupdate ketika muncul informasi baru. Tidak harus dibuat dari awal modelnya, gitu kan. Nah, ini leverage dari online machine learning untuk men-tackle uncertain problem dalam cloud. Itu dari sisi machine learning. Tapi dari sisi yang lain, bahwa namanya cloud itu memang uncertain, maka perhatikan atau consider hal ini ketika kalian berhubungan atau deal with ya dengan cloud apapun itu aktivitasnya. Ya, terima kasih semuanya, profesional Mbak Nia. Itu saja mungkin dari saya.
Baik, terima kasih Mas Hilman. Oke. Terima kasih juga. Thanks participant for joining us today's sessions. So I will inform that tomorrow morning we still have another diaspora scientist visitations from California Polytechnic State University, Prof. Taufik. He will deliver a topic on DC electricity for future homes and DC grid with distributed renewable energy sources. So you are welcome to join for tomorrow sessions. Mas Hamid atau Mas Robi, can you please share the registration link for tomorrow sessions? Okay, tomorrow at 9 AM Indonesian times. Yeah, please join us. Thank you, Mas Hilman. Oh, can we have a photo session, Mas Robi, Mas Hamid? Could you please help us? Are you there? Mas Hamid, Mas Robi? Oh, Mbak Ines? Siapa nih? Mbak Santi? No one respond.
Oke, Mbak.
Oh, oke, Mas Hamid. Oke.
Okay. Let me get the photo session. Let me count 1, 2, 3, and smile.
Smile.
Okay. Okay, once more. 1, 2, 3, and smile.
Smile. Okay, thank you.
Okay, thank you,
All
Mas Dr.
participants,
Hilman.
we already
Mbak
shared the e-certificate
Yeah,
link and also presentations in the chat box. So you can fill the link to request e-certificate, and also you can download this material on that link. Okay, thank you very much. So because today's topic of Mas Hilman is regarding clothes, so I'm wearing a blue scarf, like sky color. Okay, not related. Okay, just intermezzo. Okay, thanks Mas Hilman. Okay.
oh, thank you everyone.
Terima
Thank
kasih.
See you again tomorrow.
Yeah, see you again.
Makasih ya Mas Dr. Hilman, jaga kesehatan.
Iya,
Mbak
terima
Nia
kasih
juga
Pak
semua.
Mbak Nia dan yang lain.
Nanti kalau udah divaksin duluan kabarin ya Mas. Mas, aku boleh minta kontaknya ya Mas ya?
Ya, boleh.
Nanti aku minta Mas Hamid ya. Hatur nuwun, saya live
Ya.
dulu.
Semua ya pamitan ya. Assalamualaikum.
Waalaikumsalam.
Saya live ya, ada kelas.
Ya. Sama-sama.